Welcome to the Interval 0 video tutorial on developing RTX applications remotely across a host target connection. In this video, we will show you how to configure a target 32-bit Windows machine to receive remote debug connections and set up a 32 or 64-bit host machine to communicate with the target for remote debugging of RTX applications. There are two host target scenarios. In the first, both the host and target are 32-bit Windows systems. In the second, the host is 64-bit and the target is 32-bit. When the host is 64-bit Windows, only RTX SDK can be installed, as the RTX runtime component is not yet supported on 64-bit Windows. A host target scenario will work for non-evaluation versions of RTX 2009 and later. The host and target must be connected via Windows Network connection. In Part 1, we will configure the RTX properties dialog to receive remote debug connections. We will also create a shared execution directory on the target system, where we will later copy the binary files output from our Visual Studio project on the host. Here we have the RTX properties dialog, which you can find under Start, All Programs, Interval 0, RTX. And we're going to be changing default debug settings, so we'll click on the Debug tab. Under Debug Support, we want to select User Level Debugging and Accept Remote Debug Connections, which will enable us to communicate with the host system for remote debugging. Next, we need to configure the connection settings for debugging. To do this, we'll click the Settings button to launch the Debug Connection Settings dialog. In the dialog, we want to make sure the Transports directory shows the location of our default and third-party DLLs. Unless you move the directory after installation, you won't need to change this. We also want to make sure that Transport Ethernet is selected under Loaded. We will use Transport Ethernet to communicate with the host system, and we will specify this connection setting in Visual Studio on the host machine. Now we can apply our debug settings, and now we need to start the RTX subsystem, which we can do directly from the Control tab. Here we can see the subsystem is stopped. We can manually start it by selecting the Start button. And we'll wait for the status bar to close, and once it does, we'll need to verify that the subsystem is now running. As we can see here, it is. Now we need to create and share an execution directory on the target system through Windows Explorer. We will copy the binary files from the application we build on the host system to this directory. This is an optional step. You can alternatively use a USB drive or some other method to get the binary files onto the target system. For this example, we'll create an execution directory called test1 under target debug on the C drive. And we need to share this folder and apply permissions so that the host machine will be able to write to it. So we'll right-click and select Sharing and Security. In the Properties dialog, we'll select Share this folder, and then we can assign the necessary permissions. For this example, we'll assign full control to everybody. This will allow us to write to this folder later on during host setup. We can see here that the test1 folder is now shared, and while we're here, we're going to take note of the full path to the execution directory, as we will need to specify it later on in Visual Studio during host setup. In Part 2, we'll configure the host target connection in Visual Studio on the host machine to communicate with the execution directory that we just created on the target system. We'll also copy the binary files from the Visual Studio project from the output directory on the host to our target execution directory. Here we have our project open in Microsoft Visual Studio, and we'll use the RTX debug configuration feature available from the RTX properties toolbar to change our host target settings. In the dialog, we want to make sure the Transport Ethernet is selected just as we specified on the target system. We can then search the network for our target machine, which in this example is called TechWriter 2. Back in the host target connection dialog, we need to specify the full path to the execution directory that we set up on the remote target. For us, that's test1 under target debug on the C drive. And we can then OK the host target connection settings and build the application. For that, we'll use the Build Solution feature available from the Build menu. Now that we've successfully built the application, we can copy the binary files from the host to the execution directory on the target. First, we need to find out where the binary files are located on the host. We can do this by looking at the properties for our Visual Studio project, which in this example is called Monitor. In the Property Pages dialog, we want to look at the output directory in the General branch, which we see is set up as Solution Directory, followed by the configuration name. Our solution is called Monitor, so the output directory is monitor/configuration name, which is RTSS debug. If we click Linker and look at the output file, we'll see the location of the output file and the naming convention, which is projectname.rtss. We know what the output directory is, and our project name is Monitor, so we're looking for monitor.rtss in the output directory. Now that we know where the binary file is located and what it's called, we can copy it over to the execution directory on the target system. The easiest way to do this is to open up two Explorer windows side by side, the output directory on the host machine and the shared directory on the target machine. We know that we're looking for monitor.rtss, so once we've found that file, we can simply drag it into the execution directory on the target. We can test our remote debugging connection back in Visual Studio by adding a breakpoint to our code and then debugging using the Start Debugging feature available from the Debug menu. And as you can see, we've hit our breakpoint, so we are now remotely debugging across a host target connection. And with that, we have reached the end of our video tutorial on developing RTX applications remotely across a host target connection. For more information, see the resources listed here. Thanks for watching.